Here we are looking at molecules with 6 charge clouds. So we count a bond as a charge cloud and we count a lone pair as a charge cloud. Here we are looking at octahedral geometry. So those 2 green atoms are on the axial position and those 4 red atoms are on the equatorial position. When we are doing 6 charge clouds and we have lone pairs, we place the lone pairs on the axial position. When we have 5 charge clouds, we will put those lone pairs on the equatorial position. So remember, charge cloud 6, we first put those lone pairs on the axial position. The placement of those lone pairs, whether they should be axial or equatorial position, is important, because if you place them in the incorrect place, you will not deduce the correct molecular geometry. So remember, charge cloud 5, we put those lone pairs on the equatorial position. Charge cloud 6, we put those lone pairs on the axial position. In this molecule, we have the yellow sulfur in the middle with the 6 fluorine atoms surrounding it. In this molecule, we don't have any lone pairs, so we have a charge cloud of 6 when we count the number of bonds between the sulfur and the fluorine atoms. For this molecule, your electronic geometry and your molecular geometry is identical, which is octahedral. Here we are looking at an antimony atom in the middle, surrounded by 5 chlorine atoms, and we have a lone pair on the antimony. So now, if we look at the electronic structure, it is octahedral. But when we look at our molecular structure, it is square pyramidal. If the lone pair was not present, we would have deduced it to be trigonal bipyramidal. But now the lone pair is present and it's influencing your molecular geometry, and therefore it's square pyramidal. So when we are looking at the molecular geometry, the first thing to do is to get the electronic geometry, and from the electronic geometry you deduce the molecular geometry. The other important aspect to consider is that when you have 6 charge clouds, the lone pair should be placed on the axial position to get the correct molecular geometry. So here we are looking at antimony in the middle with 5 fluorine atoms. The lone pair are not shown, but it's still there influencing your molecular geometry. So the molecular geometry of this molecule is square pyramidal. In this molecule we have xenon in the middle, surrounded by 4 fluorine atoms. We also have 2 lone pairs, which we have placed on the axial position. Remember, if you have a charge cloud of 6, we are placing the lone pairs on the axial position. The molecule has 6 charge in total, 4 charge clouds coming from the bonds between the xenon and the fluorines, and 2 charge clouds coming from the lone pairs. So the electronic structure is octahedral and the molecular structure is square planar. Because of those lone pairs, the molecular structure is square planar. If those lone pairs were not present, we would have ended up with a tetrahedral geometry. So it's very important to consider the lone pairs because they influence your molecular geometry. So the procedure is always to first get your number of charge clouds, you get your electronic structure, which is octahedral in this case, and then from the electronic structure you deduce your molecular structure, which is square planar. Over here, the molecule is shown without the two charge clouds, and the molecular geometry is square planar.